Okay, so today we are talking about Kernmantle rope elasticity. So we are looking specifically at the parameter of elasticity. This is important with Kernmantle ropes because even when the rope is just hanging there and it's not being shock loaded, there is some static elongation. The resting load on these ropes is supposed to be 80 kilograms. 2 random rope samples with 2 different weaves were tested for the subsequent hypothesis test. We've got the 2 data sets here. The type 1 population count was 17. Type 2 had a population count of 14. So we need a few pieces of information before we get rolling here. To set up our hypothesis test, we first need to establish the null hypothesis, which is the mean of data set 1 will be equal to the mean of data set 2. Another way of saying that is the mean of data set 1 minus the mean of data set 2 is equal to 0. Our alternative hypothesis is that the mean of data set 1 does not equal the mean of data set 2, or rather, the mean of data set 1 minus the mean of data set 2 does not equal 0. So again, we have our count in each sample population. Type 1, n equals 17, type 2, n equals 14. Standard deviation, the 2 samples do not have the same standard deviation. You can see that difference here. And the level of significance that we're going to test at is 0.05 degrees of freedom. You can see reflected below 16 for population 1, 13 for population 2. We're going to need to get a t statistic to do our test. We've got the formula here. This formula is commonly used. However, for our test specifically, instead of putting the standard deviations in the numerators under the radical, we used a standard pool deviation because, as stated previously, the 2 populations had different standard deviations. Our t statistic was negative 2.227. We also need a p-value. The p-value is the smallest level of significance that would lead to the rejection of the null hypothesis. Our t statistic is negative 2.227. And using our t-table here with degrees of freedom as previously stated, the p-value is between 0.025 and 0.01. Our p-value actually is 0.01287. So what does that mean? Do we reject our null hypothesis, or do we fail to reject? The problem requires a 0.05 level of significance. Because our p-value is so small, we must reject the null hypothesis. Lastly, we're going to talk about a quick confidence interval. Upon testing with the difference between sample means, we found the confidence interval to lie, or the difference between sample mean will lie between negative 0.32749 and 0.15529, 95% of population captures. To conclude, at the 0.05 level of significance, we must reject the null hypothesis. And our confidence interval captured 90% of accurate sample mean differences. Thank you.